Welcome everyone to the Story County Amateur Radio Club meeting. My name is Clint Miller. If any of you don't know me, I'm the club president. And we had a request for a topic on repeaters and radio programming, so I kind of volunteered to give this one. So we'll see how we do with it. It's kind of going to be a pretty basic presentation, some stuff to build on anyway. Are there any announcements before we start the meeting? Nothing pressing? Okay, good. So a repeater is a two-way radio system consisting of at least one transmitter, one receiver, and a controller, which receives the signal on one frequency and retransmits it on another frequency at exactly the same time. Oh. Thanks. I did. You can take them back with you. I got a baggie for you, though. Okay, so repeaters are typically located on high locations, so they have a greater coverage area. They generally increase the user's communications range because they can transmit their signal on a bigger area than you could on your own device. They're most common on the 2 meter and 70 centimeter bands, but there's some other bands that they're on too. You'll hear the word machine. That's slang for repeater. So your mobile or handheld transceiver has a limited range due to its antenna height in respect to the horizon. And then you can be around things that attenuate your signal, like your house, your car, a fence, those sort of things. And so repeaters transfer your transmitted signal much higher levels than with a large, efficient, high-gain antenna, low-loss feed lines, and a transmitter receiver that is rated for continuous duty. So basically, we can all be using it, but you got to think when you're using a repeater in a net, the repeater is transmitting nearly constantly. So it's usually rated at that. That's why you don't want to run it at too high of a power. So a repeater gets out is kind of another slang word you'll hear, your signal, and receives a station you're talking to with a greater range and a coverage area than you could do directly or simplex. So you take advantage of the height to increase your effective transmitting and receiving coverage versus your mobile or your handheld is the kind of the idea. So here's kind of just a basic block diagram of what a repeater could be. And so, here it's sort of sitting on whatever tall structure up there. And, we have to assume that these guys probably couldn't talk to each other for whatever reason. They're too far away. There's a hill, whatever. And so, they're transmitting through the repeater to the other station. So here's a basic block diagram of how this works. You've got an antenna and then a feed line. And so the signal goes up and down the feed line bidirectionally at the same time. So there's RF going different directions in there. And we have a thing in the middle called the duplexer. Some people refer to those as cans, and I'll show a picture of why they call them cans. But the duplexer basically splits the incoming signal from the outgoing signal and sends it down different coax. One goes to the receiver, and then the receiver splits off and converts that received RF energy into audio signal, and that audio signal goes to the controller. And if the controller says, yes, this signal I want to repeat, then it activates the transmitter and it sends it some more audio. That combines it back into RF. It goes back to the duplexer. Again, it inserts it onto the feed line, runs it up to the antenna, and then it gets transmitted. So that's the basic block diagram of how a repeater works. So in order to listen and transmit at the same time, they have to use two different frequencies. They're on the same frequency, they would interact. So as a general rule, the output frequency or the transmit of a 2 meter repeater, if it's below 147 megahertz, then the input or listening frequency is 600 kilohertz lower. So the kind of the take home there is if it's 147 or below, it's what we call a negative offset. And then if it's above 147, then it's referred to a positive offset. And so the 2 meter band is the only one that really has this kind of half one way, half the other type of situation. It's just a holdout from 40 or 50 years ago when they started installing these things, and that was the equipment they had, and kind of how it all developed. So here's some standard repeater input offsets. So you can see they kind of vary. The reason why 2 meters is so narrow is we just don't have enough spectrum to really space them out. There's not enough RF space there. And so you'll see if you ever find the 2 meter cans that I'll show you, the duplexer, are pretty big. You're not going to go portable with that. But a 70 centimeter duplexer, because it's, basically 10 or 15 times further apart, they call it a 6-pack. It's a little device that's this big, and it fits very nicely in a portable case. And you can take a 70 centimeter portable repeater and set it up, and it works just fine. And the two signals don't cause any problems because they're so far apart. The duplexer can be much smaller. Do note that most modern transceivers will automatically set the offset and direction. It'll say, oh, you're on 147.24. I need to have a positive offset. And so there's a little plus or minus that'll show up on your screen. So then there's this thing called tone, or continuous tone coded squelch system. And so it's a sub-audible tone, meaning you can't hear it, but it's there. Maybe your dog can hear it, but it's a tone system that's sub-audio, and it's used on most repeaters. A lot of people call it a PL tone or a private line, and that's Motorola's trademark term for when they came out with that. They trademarked PL. So tone squelch is an electronic means of allowing a repeater to respond only to stations that encode and send the proper CTCSS tone. So if you have your radio programmed wrong and you're not sending the right tone, the controller will not activate the transmitter. It'll receive your audio, but it's not got the right tone. If you don't have any tone and the repeater requires tone, you won't activate the transmitter. And so we added tone on the repeater here 7-8 years ago, I think. Boone added tone on their repeater somewhat recently. The reason why we typically do that is if it's an interference signal coming in on that frequency, it would activate the repeater if it didn't have tone. The repeater didn't require tone, so they were transmitting noise that they didn't need from some local RF source. And so tone is a way to keep out unwanted signals from activating the repeater and sending that out. So it allows the repeater to accept and pass the signal, and it prevents it from the unwanted signals from activating. If a repeater is set up to operate where the tone is 114.8, and that's our typical central Iowa tone frequency, and it's heard by the receiver, then it will allow the transmitting station to access if using that tone. So you have the right tone, you can use the repeater. Your station does not transmit that tone. The repeater hears the signal, it just doesn't pass it on through and back to the transmitter. So here's the common list of tones that you'll find out there. Just know that there's a bunch of them, so we got a lot to choose from. So let's talk about what happens when you key the microphone on a radio. So you turn your radio to the 147.240 machine. That's the Story County repeater here at the USDA on the water tower. And you listen to see if it's in use. Nothing heard, because you don't want to talk when somebody else is talking. You want to be polite. So you assume that you're in range of the repeater. You key the microphone and you put out your call sign. This is K0GR, listening to the 2.4 machine. That means I'm listening on this repeater. Sometimes you say that and you think, why are you saying the thing that's obvious? Well, people sometimes have their radios on scan or they're driving and they don't look at the signal, the radio face and know what channel they're on. And so that instantly tells them, if they're just listening, what repeater you're using. So that's why they say that which machine they're on, especially if they're kind of new to the area and don't necessarily know how everything works. So then you release the mic button, okay? So you've transmitted your call sign into the repeater. What happened during that? Well, again, antenna, feed line, duplexer, went over to the receiver converted it to audio, went through the controller, we had a good tone, transmit audio, went to the transmitter. The controller also had a control line that key the transmitter to make it produce energy, makes RF out through the duplexer and out to the antenna. Okay, so the antenna, which is on a very high water tower, picked up the signal on our 147.840 repeater. Again, I said 2.4 repeater, and this says 8.4. It's listening on 8.4 because of that 600 kilohertz offset. Okay. And so it heard that, it sent it down the feed line to the duplexer. The RF was sent to the repeater receiver and converted to an audio signal. So that audio signal, if you hooked up a speaker to that output, it would sound just like you would hear on your handheld. That's just audio noise coming down that wire at that point. The audio is sent to the controller, the brains, which decodes the tone. And if it's the correct tone, then it's transferred back into, it's sent back to the transmitter, which makes it a much stronger RF. So it might receive it off your 5-watt handheld, and it transmits it at 25 or 30 watts or 50 watts, and it goes to the output. The RF from the transmitter goes back to the duplexer, through the feed line, and out through the antenna. So that's why a little HT running a low power can get the advantage of a much higher and much stronger transmitter. And so your little handheld can cover 30 miles if you're within the range of where the repeater can hear you. So anyone monitoring the 2.4 machine heard your transmission, and since the radio waves traveled the speed of light, the split second that you keyed the repeater, everything in that sequence happened, and the person on the other end was hearing you talk just milliseconds after you keyed it up. And so that energy was coming in and going out at the same time as you were saying your words. And so it's kind of fascinating to think that we can build a device that does all that at the same time. There's not a recording and it waits and then it retransmits. So a mobile station that heard you on that output frequency, they're listening on the output frequency, the 147.24, because that's their radio's tuned and that's where they're listening. They heard you. They decided to key the microphone, and the whole process starts over again. That transmitter keys down and sends out that energy. So this is currently what our repeater looks like. Why did that get moved to the middle? Stand by. Let me see if I can fix that real quick. Okay, so this is the current repeater out at the W0YL site. So this big white thing, I got a laser pointer.
Oh, the bottom rack is the power supply. It just 120 in and 12 volts out, and I think it's good for about 20 amps or something. And then the one directly above that is the transmitter, and it's yeah. The reason that one on top of the other, there's a fan that cools the power supply, also cools the transmitter heatsink, and then then the UHF receiver, then the controller, and then the repeater receiver, the VHF receiver. And you can see the cavities. Oh, I'm stealing Clint's thunder here. Oh.
Receiver.
The receiver is a Micor. It's a Micor base station receiver that we've added some shielding and some feed-through caps in that.
So this was the latest technology in the 60s?
What was that?
Micor is the newest technology from the 60s?
It came out in 72.
Oh, 72? Okay.
Yeah, well, they were, pretty much every cop car had a Micor in the trunk. Back in the 70s. And then the cable as big around as your thumb, taking all the wires up to the control head. And they were $2,000 a piece. And
back then,
now they're to buy a new one when they were being installed, and now you can buy them for $20. So it's still a very nice radio, kind of bulletproof, and it has some advantages over the new ones, but the disadvantage is they're crystal controlled, and there's nobody that will make crystals.
Thank you, Dave. Okay, so that's our tour of the little the W0YL repeater. Now, there's some other interesting things that we could talk about with repeaters and ways to be able to use a repeater with some extra pieces. So a crossband repeater is one that receives a signal and transmits on different bands. So instead of being 600 kilohertz apart, it might be 250 megahertz apart. And so an example is receive on UHF or retransmit on VHF. And since they aren't close together at all, we don't need any kind of special duplexer. Many of your mobile radios in your car will function as a crossband repeater. And so that's something you can do. And so there's an example of, yeah, Eric.
I want to say I kind of disagree with that. Don't the TMV71s have a built-in? You still need a duplexer, it doesn't need to be as big and.
No,
Don't they have a
using
duplexer
yeah.
inside them?
Yeah, the Kenwood TM271 or sorry, V71, right?
Yeah.
Yeah, and the Kenwood D710. I don't know if the 700 does, but I know my D710 does, and it's the same radio with a different control head. It's the two radios are interchangeable.
There's no,
ICOM and Yaesu, I think, make some that are doing this.
they don't have a duplexer in them at all?
No,
they have a diplexer, it's part of the radios.
and yes, internal. It's in there.
That's-
It's in there all the time. Yeah. So all it is, you just basically turn the radio off, hold a button, turn it back on with that one button, and it goes into crossband repeat mode.
But you still need some filtering.
No, it's in the radio.
It's built in.
Yeah, it's built into the radio.
Yeah,
Nothing external is required.
I know that, but you need filtering somewhere. It has to be in the radio or outside.
it's in the radio, yes.
Built into the.
Yes,
Yeah.
it's all internal in the radio, so you don't have to have anything other than the radio out of the box to use it as a crossband repeater. Yep. So in this scenario, you can basically just deploy a crossband repeater, and a handheld and a vehicle can talk to each other through that. So like the handheld may be on UHF and the vehicle may be on VHF, but because it's crossband, it works for that setup. So where this is helpful is you can't get to the repeater on your handheld. You're just too far. You're out in the woods. So you park a crossband repeater, maybe it's the mobile in your vehicle. You leave the vehicle powered up, at least, hopefully you don't drain the battery, but you can deploy your crossband repeater somewhere, then go off your handheld within range of that mobile, and it will, in this case, transmit on UHF up to the crossband repeater. This device is already programmed to use the repeater, so it goes in and out on VHF like it normally would. And then the other site can hear that. When they transmit on VHF, it comes back to the crossband repeater. It takes the VHF signal, flips it over to UHF, and sends it out to the handheld. And so that works pretty well for scenarios where you're distant with a handheld, but the mobile can get in. You've got an antenna on the roof, that sort of thing, camping, whatever. So that's pretty common. Another way you can do it is you can hear the repeater. It's putting out 30 watts, 50 watts. It's on a tower. You can hear it fine, but your little 5-watt signal is just not enough to get into the transmitter or into the regular repeater. And so this is called like a one-way crossband repeater, is that it only transmits what it hears on UHF. It doesn't really transmit on VHF at all. It's kind of ignoring, it transmits on VHF. It doesn't listen on VHF at all. And so it doesn't pass the repeater back. You can hear it directly on your handheld. I've used something like this scenario. Trying to think, maybe it's the next slide that shows a little better. Yeah, this is one where you can do things like, you're in a noisy environment, you can't hear the repeater, so you use the vehicle outside to get into the repeater. I've actually had to do this. We were on a communications exercise at Mary Greeley. The EMTs came in and turned the air conditioner on in the room I was in, and I lost the repeater. I'm 2 miles away from it. I could not hear it at all. And so I had to go outside and turn on my Kenwood D710 in crossband repeat mode, pick a UHF frequency, go inside with my handheld and talk through the crossband repeater to get into the repeater to talk to Des Moines, because they were sending us simulated patients out of the airport. And so in that scenario, crossband repeater saved me from being able to have to go stand outside and then run in and out whenever I needed to pass information. Okay, so now we're going to shift to radio programming. So to use a repeater, you need to know certain things to program into your radio for the user. You need to know the transmit frequency of the repeater. You need to know the receive frequency of the repeater, the tone, if it's required, and if the repeater is actually transmitting tone. Not all of them transmit tone, and we'll get into how that difference between whether they receive or whether they transmit. If you're going to program your radio just for simplex, all you really need to know is the frequency. In and out's the same frequency, and then are you using tone for whatever it is you're doing? If it's you and your buddies and you don't really want to hear anybody else, you may run tone just so you don't have random signals opening up your receiver. And so you can run tone on simplex also. You can do manual programming on the keypad of a lot of radios, or you can use software to program them. So tone, again, we'll get into this one more time for review. Most radios are able to send and receive tone that must be set for each channel. And so as you toggle through the tone button on your radio, you usually end up with a T for tone on the display, or you'll end up with a CT. And so tone, when you see that, it means that the radio is transmitting tone, so you can open up the receiver, the repeater, and get through. The CT on your radio is a kind of a confusing way to put it, but basically what that means is your radio won't open its receiver squelch unless it receives a tone from a repeater. Yeah.
And Yaesu typically displays that as TSQ on their radios.
Yeah. So I think ICOM and Kenwood are using the CT label and TSQ for Yaesu. And I think the Chinese ones, I think, are CT also. A lot of the Baofangs and those. I think is how they display it. So just remember, tone is I'm transmitting tone. CT or TSQ is I'm transmitting and I require receiving tone to open. And so the way that's helpful is if you live near a noisy site and there's something on the repeater output frequency that's opening your squelch, it's hard to listen to the repeater on standby because you keep getting static noise. So if the repeater transmits a tone and you can squelch your radio, you don't hear that. Or if it's a dual digital repeater and analog repeater, you'll hear for on and on and on. And it's because somebody's using the digital half of the repeater. So that's where you'd want to set the CT or the TSQ to filter off that digital signal because they don't send out a sub-audio tone with those digital signals. You'll also see DCS. It's not really used a whole lot, but essentially it's a digital tone. And so there's digital codes. I've not ever run into a repeater that we had to use digital tone with it. And then the fourth option is usually a blank, or I don't think it says none or anything. It just kind of disappears. And basically the receiver is only going to open the speaker when it's just receiving a strong enough signal. So your squelch setting is really the only thing keeping you from just hearing noise. So how do we get all these tones and repeater frequencies? Well, we have the Iowa Repeater Council, and they coordinate all of the amateur radio serving repeater frequencies in the state. They are recognized by the FCC as the single authority for repeaters in Iowa. And so you coordinate frequencies in order to minimize interference and to maximize the use of the spectrum. We want to make sure we stack all the repeaters in there as tightly as we can. You get every bit of spectrum out of it, but we want to make sure they don't interfere. So the two repeaters on the same frequency are in the corners of the state, or they're not close enough to another repeater in another state. So if you turn on a repeater without coordinating and you cause interference to somebody else who is coordinated, they can make a complaint to the FCC. The FCC will tell you, you are not a coordinated repeater. You're interfering with a coordinated repeater. You need to cease your operations. You need to turn your repeater off. So that's the benefit of getting a coordination, is that you kind of are protected on that frequency in that area. And so if you have more questions on the Iowa Repeater Council, the frequency coordinator for Iowa happens to be Paul. So he's the one that gets to deal with all the requests and the renewals, to make sure everybody's still on. So every so often, maybe once or twice a year, we publish the list of repeaters. And so this is a really good reference just to kind of know what's out there in the state. So I screen grab the top of it. And so you get city, you get output, you get the call sign, and it's usually a club or an individual. You have to look it up. The access, what this is recognized right here, 114.8, that is our tone for the access to the repeater. It's wide FM. That's kind of the type, where this one's a digital fusion repeater. And then there's some codes that are up there to tell you what the kind of the extra features the repeater has. It can be assumed from this that everybody's following the standard offsets. And so if it's a 147 or above, it's a positive offset of 6 kilohertz. So they don't put that on here because everything's following the plans that are out there. And most radios recognize that the offsets anyway and put them in for you. But we do have a tone plan. And so I was broken down into this map to say that in certain areas, we're going to use certain tones. And I'll zoom in here. And Central Iowa is using 114.8. It's our standard tone plan. Now, anybody who's programmed a UHF repeater in Central Iowa will say, but that's not the tone you use on UHF in Central Iowa. There's sort of been this long-term understanding that everybody seems to be using 154, I think.
151.4.
151.4. And any new repeater that we put on UHF, we're pushing to 114.8. That is the frequency, the sub-audio tone frequency for this area. We want you using that. I'm sure 40 years ago, there was a reason that they used different tones, but
Because they got a bunch of radios that had
right.
responders in them.
So
Yep.
they bought 50 radios of the police auction, and they all had 151.4
Yeah.
in them. So they choose that tone crystal. Okay, so we're going to program a radio. Step 1 is to read the manual. Step 2 is to reread the manual. Step 3 is to read the manual again, because every radio is going to be different in how you try to program a radio. Everything's got its own unique methods. One manufacturer doesn't even use the same methods on model to model. And so you really have to understand the terminology your repeater, your radio manual says, like TSQ versus TS or CT, sorry, CT for your tone squelch on your receiver radio. So this is probably the slide some of you came to see, and I can't get into a whole lot more detail than this on a standard Japanese radio procedure. So we're talking ICOM, Kenwood, Yaesu, Alinco. They all tend to follow this method to manually program the repeater. Okay, so the first thing you're going to do is put the radio in VFO mode. What that really means is it's not the channelized memory section. We've already saved memories into channels. This is, you turn the knob and the frequency goes up, turn the knob, frequency goes down. It's kind of wide open to whatever you feel like picking. And so that's called the VFO mode. So then you set the frequency of your receive to that. So in this case, 147.24 is the transmitter of our repeater, is the receive frequency that you're programming in. It's your opposite of the repeater, right? So first at 147.24 is that is your receive frequency. That's what you're listening to most of the time. You make sure that it's got the right shift in terms of spacing and the direction. Most radios, again, are going to do that automatically, but there is a function in there. You can go in and you can tell it to do the opposite, or you can turn off the receive, the shift. So usually it's toggle between positive, negative, off, positive, negative, off. It's usually when you push that button, it'll cycle through those. You can set the tone if you need for that repeater. And then you're going to set it whether it's tone or tone squelch or digital or none. And then you're going to store that into a memory slot of the radio. And because you have the offset turned on, positive or negative, the radio knows automatically that here's my receive frequency. I've got an offset, so I know what my transmit frequency is. And you store that as a group into that memory slot. And then a lot of those radios, you can go in and you can assign it a name so that you kind of remember what that was. Some people remember them by frequency, some people remember them by call sign, some people remember them by city. And so they'll see a lot of them that just say Ames or ISU. This is on the ISU campus. It's the other here compound. Okay, so now the Chinese radios, sometimes you have to do this method, and you'll see that the thing that's different here is right here, we don't set the offset or the direction. We're going to set the receiver and into a memory slot. Then we're going to set the transmitter and save that also. And you do a special button push to save the transmit frequency on top of the receive frequency so they don't overwrite, they're paired up. And so you got to read your manual to know exactly what button pushes that is. You get those two kind of paired together under that same channel. So you're programming channel 10, you put in your receive stuff, then you flip over to the transmit frequency, you push the special button sequence and then save it to channel 10 also. This is, oh, this is the transmit frequency. And so then they're paired up in the memory slot 10 of your radio. But a lot of these Chinese radios don't allow you to put names on them. You have to use software to get the names on them. Not all of them, but generalizing, that's the thing that you might run into is it's not automatic that you'll be able to put a name on them. So it's kind of just a warning that when you're trying to program a Baofeng, it doesn't work the same all the time. And this is usually why you have to do this special button push to put the transmitter in separate. Much easier to do is to invest in computer radio programming. And so you're going to start with a cable, plug that into the computer, plug that into the radio, you turn the radio on with usually a special sequence that puts it into programming mode. And then you're running software on your computer. And so you're going to basically turn the radio on in that special mode and read the program from the radio and save. That's very important. Never push program to radio without first reading it, modifying the code plug, as we call it, that comes out of the radio, and then you push it back with the changes. Because there's a whole lot of things specific to that radio. What's the power on sequence? What's the call sign? Is there a password? How do you have your memory channels grouped? There's just a whole lot of things that make that radio function correctly that aren't just the individual channels of the repeaters. So that's why you always want to pull the code plug off, make your changes, and send it back. And some of the better software allows you to copy and paste the changes in. So if you've got an Excel file, you can just paste them in there. You don't have to go in and type every frequency. Some you do have to type every frequency because they're just not great software. But it's still easier to type on a computer than it is to try to turn the knob and find the exact frequency and try to save them that way. I always recommend you save the program file with a unique name, including a date. And so I kind of have a lot of radio programming files on my computer that say factory original, just whatever default from the factory. I save that first thing when I get it into the software so that I have that as like a baseline. Then I make my changes, save it again with usually a date, and then write the program to the radio. There's also a way to do cloning. Basically, you could connect a special cable between your radios, put them both in cloning mode, and then do a key press on the master radio and send the data to the donor radio. So it's a quick way to duplicate programming in multiple radios. Okay, so the programming software options. There's manufacturer-specific software. Some are free, and most of the Kenwood stuff's all free. And so I've been happy with that. I was digging around. Some of the new ICOM stuff still has software. They call it cloning software. I opened it up. It doesn't clone. It's just programming software. They just have a weird name for it. So I thought that was kind of odd. There's some third-party companies making software. Notably, RT Systems is the one that you hear out a lot. When you buy a radio, they tend to put that as the accessory page. Yaesu really doesn't have their own software. So the only way to computer program a Yaesu is either to buy the RT Systems setup or another option here I'll talk about in a second. RT Systems uses a unique cable and unique software. And that cable only works with that piece of software. If you want to program a different model of radio, you have to buy a different cable. It might be physically exactly the same, but they've got a chip in it and it says it's only for this radio and this software. And so you have to buy their $30 or $40 package for every single radio model that you have. And that's why I don't own any of that RT system stuff, because I just don't like supporting that concept. And so then it comes in Chirp. Chirp is a free open source system that people are basically volunteering their time to develop this. And so I went in and counted, there are 56 brands supporting 530 radios for models. So they support a lot of different stuff. There's brands of stuff I've never heard of in there. And so if any radio that's not supported and you really want to support it, you can actually volunteer to send the radio to somebody and they will hack the firmware on it, figure out how to program it, add it into the software, and then, now you can use Chirp to program your radios. So that's how we got to this many radios, people mailing them in models to try out. So Chirp is a pretty good option. It's not perfect, but the price is right, and it does a lot of stuff. And it's a good way to get programming from one model radio to another, because it has a common naming structure to the different repeaters. Okay, that's it. Other questions? Yeah, Chip. Skip.
Okay, I turned on the handheld. And how do I know if it's in? What mode, VFO mode?
How do you know if
Or
it's in
not?
VFO mode?
Yeah,
We turn the knob and see
okay,
how it goes up and down in frequency.
so I don't get a screen indication.
Right. Yep.
Okay.
Yep. If it was going up and down in channel, it would jump a bunch and it would have
Okay.
different numbers on the screen for the channel number.
And the alternative to VFO mode is what?
Memory
Memory mode.
Yep. And so
Okay.
it just said memory on the
That
screen.
one says memory.
Yep. So now when I turn, now you're back to VFO.
Yeah.
Go back to memory. See how this number right here shows up?
Okay, that's channel one.
1, and that's channel 3.
Okay,
So you've got channel 1 and channel 3 at least programmed in that radio. That's how you would know.
okay.
Yep. You good?
Then I had a question on duplexer.
Okay.
Are duplexers active circuits or passive like filters?
I would say that be pretty passive.
There's no amplifiers.
Yeah.
So
It's
passive,
Just the tune circuit.
right?
One half of it is tuned to the frequency of the transmitter, and the other half is tuned to the frequency.
So it does fit the description of cans.
Pardon?
They are cans,
Well,
part of the tune
it's
actually, the tune circuit is a rod inside.
inside the can.
That's
Okay,
exactly
yeah.
the right length. They've got a little screw on the top so you can change the length of it and make it
Okay.
exactly, because has to be exactly right or it won't work.
Okay, thank you.
They're highly sensitive when I've helped program them. Micro little changes make a difference if you're trying to get it just eke every little piece of RF out of it. Okay, yeah.
If I want to use my mobile in the car as a crossband repeat just for myself, so I
Yep.
have both frequency not connected to a repeater, what frequency should I be using? Should I be using the simplex frequency?
Yeah, I would use the simplex, because if you use a repeater part, there's a band plan, right?
Yep.
The VHF, the UHF band plans. If you use a frequency in the repeater port of the band plan, you may interfere with somebody's repeater that's coordinated. So you need to use, in that scenario, simplex frequencies, because then they're wide open and not coordinated.
Do
And
you
so,
recommend to use UHF versus VHF for
um,
transmitting and receiving?
it would depend on the radio you've got. If you're indoors, you're dealing with, buildings, cloud cover, because UHF tends to go through obstructions better. Out in the open, UHF doesn't go as far in terms of distance. And typically a lot of mobiles transmit lower power on UHF than VHF. You have to look at the specs. So otherwise, no, it probably doesn't mean significantly, but if every bit matters, those are the things I'd look at if I was deciding if I'm going to use VHF or UHF on the handheld. You can even program a crossband repeater so that everybody transmits on VHF and everybody receives on UHF. So you basically program a split on your handheld, and then you're not on VHF and I'm not on UHF. We're both on both. And so it's just a different way to program it. You could actually use 2 crossband repeaters at different sites so they don't interfere with each other, but they can hear each other. And it would act as a VHF or a UHF repeater. There'd just be an extra RF path hop in the middle. So if you had 2 of them, you could build a regular repeater on a 600 kilohertz split by having them separated by a mile or 2. Yeah. What do you think for distance? How far apart? Half mile?
2 antennas on the same tower, just vertically separated.
Oh,
By
with a little bit of
100
filtering,
feet
probably,
or
right?
something.
Would they have a
with the
little bit of
600
filtering?
Kilohertz offset still.
Yeah. But you say they wouldn't need cans at all, even if they're on the same tower?
Well, yeah, it depends on how good your receiver
Yeah.
filtering is and stuff like that.
Yeah. So,
In Cedar Rapids, they pretty much don't use duplexers. There's a AM station at 600 kilohertz.
Yeah, WMTs on 600 kilohertz.
oh, so that,
That very strong AM station, I don't know how much power it is, but it's that 600 kilohertz signals there, and it mixes with the receiver or the repeater transmitter, and it ends up, the heterodyne ends up right on the repeater receiver, and then there's no way to filter that out because it's on that frequency, that it's the same frequency and so they can alleviate that problem by having a split site repeater.
okay.
And
Yep.
they probably would not be able to do close, they'd have to have a half a mile separation. I don't know what they're using now. They used to have, there was 2 hospitals in Cedar Rapids, and they had the transmitters on one and the receivers on the other one.
Interesting.
Collins now, Rockwell Collins site.
Yeah.
But, yeah.
So that between the 2 split sites, are they using a UHF link?
Yeah.
So essentially that is a 2 crossband repeaters.
Right.
It's built very specifically for that use case. They're coming in on VHF, UHF from site to site, and then VHF back out.
Yeah, it's just using, instead of wire to get from the controller to the transmitter, they're using a VA or UHF.
Right.
And that link frequency is unpublished.
Oh, okay. Yeah. So if you couldn't hear, Paul said that
It's coordinated.
the link frequency between the 2 sites is coordinated but unpublished, so nobody could get in there and mess with it.
You can find it.
Oh yeah. Yeah. Yeah.
But by principle, we don't
Yeah.
publish.
But you coordinate it so that someone else doesn't try and use
Correct.
the same frequency for their link.
Correct.
Any other questions? Anybody online?
Yeah,
Go ahead. I'm not sure who that is.
somebody had questioned what's inside the can. Well, on VHF for amateur splits of 600 kilohertz, it's air. I mean, the can itself is the tuned circuit. So basically, if you took the lid off, the only thing inside is the coupling coil or coupling link, and that's it. And the knob on the top, you're actually varying the dimensions of that cavity, if you will. So just throwing that out there.
Thanks, Chuck.